Welcome everybody to another VITA Learning webinar. Today we're going to have Paul Richardson, my colleague here at VITA, go over the VIGO workflow of the digital dentures. It's a very unique program that we do on this, that Paul does, because we kind of combine both the virtual webcams along with a overhead camera that we can go step by step with you in a pseudo hands-on environment. So Paul should be on as well and listening. And so we are going to make sure that everyone's kind of following together. This kind of is a show me and do it type program. So Paul will go through the workflow with you, and then you will follow along. Everyone should have their kit that's arrived. We will have it muted in the background because of the interference, but there is a question box on the right-hand side of your panel. If you have a question or you need me to stop or ask Paul a question, or Paul needs to go over something, just let us know. Just by typing in that question box and so forth. And then we can go from there. So if you do fall behind, let us know. And then at the end of the program, we'll have additional time for question and answer as well. So we'll do it throughout. If you need to have a stop, let us know through the question box. We'll stop, we'll address your question, and then we'll move forward. So with that said, we're going to go ahead and start in a few minutes. So it is going to be recorded. Now, the recording is only for you. So we are actually going to record the session, the workshop, but they will be a non-public link that we will be able to send to you so you can view it on YouTube channel, the VITA North America YouTube. And it'll be specific for you, for those that have registered, because it is a paid program. And we want to make sure we just don't open it up to everyone, because that would be unfair to have you pay and everybody else gets it for free. But we will send you a link in which you can go back and review any aspect of today's webinar with Paul. So it'll be posted on the learning website specific to you as an attendee. If you need CE, you'll receive an email from VITA Education Department, and also at the time that you registered, it should have asked you if you wanted CE. If not, please email us at marketing@VITANorthAmerica.com or education@VITANorthAmerica.com, and we'll get back to you for any CE. Those of you that need MBC CE requirements hours, we go ahead and we will submit, once you give us all your information, we will submit that directly to MBC for your CE. And then, of course, we have other videos as well on the VITA Learning channel of the YouTube, VITA North America YouTube. So please visit us at the VITANorthAmerica.com/courses, and you'll have additional courses that you may want to register for as well. So Paul Richardson comes from a long background of dentistry. His father's a dentist, very knowledgeable in practicality, the functionality of digital dentures, as well as dental technology. He's got an extensive background with implants, with prosthetics. So he would be able to answer pretty much any of your questions that you may have today. And again, we'll address those as they come through, and or at the end of the program, in which we'll have you have an opportunity to ask additional questions as well. So today's VIGO hands-on digital denture integration into your workflow, the beginning, we're going to go ahead and start that. So make sure everybody has their kit in front of them. So make sure there'll be up front some stuff that Paul will go through at first, but then it'll be a time where you'll need to do the hands-on portion. So just make sure you start gathering your kit ahead of time so that you can follow along. So Paul, if you are there, I am going to turn this over to you. You are now the presenter, and we will now see your screen.
Excellent. Hi, guys. Welcome. Thank you so much for joining me today. We are going to be talking digital dentures that, we've reached a point where digital technology and digital manufacturing have, gotten good enough that we can really, apply it to our, workflows, our processes and stuff that, if you guys have used digital technology for crown and bridge and that kind of stuff in the past, then you know that the advantages of doing this digital is consistent and predictable results, savings of time and labor, and the streamlining of workflows. So there's lots and lots of advantage of moving to digital. And like I said, because now that the technology and the manufacturing have gotten to a point, we're starting to include dentures in that digital process as well. So that's what we're going to go over today. Is we're going to talk about digital dentures, some of the different workflows, some of the different options that are available, and we'll be going through that. This is a hands-on workshop. So if you guys have the software in the USB that I sent you guys, there is the scan files for all the demos that I'm going to do today, so you guys can follow along. If you don't have the software, that's fine. You guys can watch and you can see all the different workflows, and hopefully that will help educate you as you make your decision on how you're going to do this moving forward digitally. And then we will move into the hands-on. I will switch to the overhead cam, and we'll go through everything that came in your kit, and we'll go through the the finishing, the finalizing of a digital denture. Okay. Like Jim said, if you guys have questions, please type it into that question box. If you get stuck on something or you have questions, please stop me, let me know. I'll save some time at the end for more questions if you have some then. But this is full participation. This is a workshop, so please let me know as we're going along. To start out, the tooth library, the digital tooth library that we're going to use is available for both 3Shape and exocad. Okay, I'm going to start with how to download those libraries and get them into the software, and then we'll go through how to actually do a design in the software. So I'm going to switch over here, switch my camera. And let's start with 3Shape. Okay, so for those of you who are running 3Shape, now for both of the softwares, the VITA VIGO tooth library, which is a digital tooth library, is available free for both of the softwares. And for the 3Shape, you don't even have to call me or request it or anything. You can actually get it directly from your from your dental manager or from your control panel here, actually. And there's a couple of places that you can access that. In the dental manager, you can either go to the nut here, which is the control panel, or on your desktop. Let's see, there's usually a shortcut on your desktop to the control panel. Either way is fine. In the control panel, now you guys can see I'm running version 2020. I think it's 20.1.2, if I remember right. The minimum requirement is 19.3. If you're running anything earlier than that, then you need to upgrade to at least 19.3 to do the digital dentures. I encourage you to upgrade to the 2020 because they actually added a few features that are specific to digital dentures in that latest version, and I'll show you what those are, and we can play with them a little bit later. But that's what you're going to need to run this. So in the dental system control panel, down here under tools, we're going to go to the download center. In the download center, we're going to change our topic here to download libraries. We'll give it a second to update. Think about it. And there we go. And this one right here, this VITA Bionic VIGO, this is the one that you want to select. Okay, you can see that there's actually another one in here, this VitaPan, which is our Excel and Lingo form. And the VIGO, for the most part, replaces that. So if you've already got that, it's fine. If you don't, I would not include it. I would just do the VITA Bionic VIGO. Check that. And then over here, you're going to hit Import. And I've already done it, so I'm not going to. Save your changes. Yes. And what it's going to do is it will restart your dental manager. Okay, so this should actually close out and restart, and then the VIGO tooth library will be available for design. Now, this also works if you have this set up in a server configuration so that you have like a master station and then several design stations. That if you've got designers designing, it's totally fine. You can still go into the control panel, download that library. Your designers just need to know that they can continue to design, finish up what they're doing. They'll just need to, when they get done, save, restart their dental manager before that tooth library is going to be available. So that's how you get the tooth library for 3Shapes. Pretty easy. If you guys need, you guys will have this video to refer to. I also have PowerPoint or PDF tutorials on all of this. So if you guys need to know specifically, I can send that to you. Just send me an email, ask me for that, and I'll send it over. But that is how you get the library for 3Shape. Now, ExoCAD is a little bit different. That in ExoCAD, you actually have to request the library. It's still free. You just have to go on to ExoCAD's website and request it. So you're going to go on to ExoCAD's website. And they've got under integration, they've got a place for libraries. And then here, VITA Bionic VIGO Full Denture Library is what you're going to select. And then they're going to ask you to fill out this information. They're going to ask you for your serial number. If you click on this little question mark on their page, it will tell you how to find your serial number, just in case you don't know what it is. And then ExoCAD will email you a link to download the library. Okay. They will also email you this PDF, how to install the libraries. I suggest downloading it and reading that also. But essentially, it's going to look like this in there. And so for full denture tooth libraries, this is what you're going to look for. The most difficult part of this is actually just finding the folder to put this library in. And it's different depending on which version of ExoCAD you have. And what I mean by that is that ExoCAD actually licenses its software to other companies. So Gerbach has a version of ExoCAD, Noble Biocare, Zirconzon, all of them have different versions of ExoCAD. And so depending on which version of ExoCAD that you have, this library or folder location can be different. So you can see here it says Dental CAD app is the folder you're looking for. Now that is just a placeholder, again, depending on which version you have. In my Gerbach system, it actually calls that Ceramil software. So instead of Dental CAD app, it actually says Ceramil software. So depending on which version you have, this Dental CAD app may say that, or it may be a placeholder. Okay. Once you find it, then you simply need to drag and drop the tooth library into that folder, which is pretty easy. So let me show you what that looks like. So on my computer here, let's see, the C drive, ExoCAD, and see mine actually says Dental CAD app and library. and then prosthetic tooth sets. And here's going to be a list of all of the ones that are available. So when you get the folder from them, they will have all these VITA Bionic VIGO. You simply drag and drop them all into the folder, prosthetic tooth set, so it looks like this. And that is all you have to do. So that's, like I said, once you find the folder, it's a pretty easy, just drag and drop. It's just finding that folder. And again, I have tutorials on this. So if you guys need that, please let me know and I can get that to you. So that is how you get the VITA VIGO digital tooth library in the software. Like I said, right now it is only available for 3Shape and exocad. It is free, and you can either request it from exocad or download it directly from 3Shape. Once you have that in the software, then we can go through designing a digital denture. So that is what I'm going to do next, is I'm going to show you how to set up the order forms in the two softwares, and I'll jump back and forth so that everybody can follow along, and I'll show you how to set up an order form. So in 3Shape, in the Dental Manager here, you can either go to this icon here, which is New, or you can right-click and go to New. Either way is fine. It'll take you to the same place. This stuff I will let you fill out however you want to. Today we'll call this demo. Now when I'm setting it up here in the order form, I need to tell the software, I need to select at least second molar to second molar. And if I hold Shift, it will select all the ones in between. Now, whether we use these second molars or not in our final design, we can decide later, but it needs to see at least second molar to second molar for it to recognize it as a digital denture. So again, we can press second molar, hold Shift, click the other side, and it will select all the ones in between. Now, currently, the approved workflow is a full upper over a full lower, which is what we're going to go through today. A full upper over natural dentition, dentures on implants, all of that is kind of coming in the future. There's a lot of that stuff we're working on in the background with the software and some of the workflows. And this is a basic intro, so we're going to just go through the basic workflow, and that as more features become available, I'll let you know. So again, full upper over full lower, second molar to second molar. And the first thing we want to do is tell it that it has teeth. So we're going to select anatomy, and we want to make sure go over here to this very last one here, which is called artificial tooth, that we want to tell it that these are artificial teeth. Now, if we go over to the plus sign, I have mine set as the default, but once you have the library in there, you can scroll down to the Bionic VIGO artificial teeth. Now, because a lot of labs and clinics and clinicians and stuff use this as communication back and forth, you can add tooth color and that kind of information in here as well. As far as manufacturing process, manufacturer, it really doesn't matter. What we're using is carded teeth. We're actually not manufacturing anything. But the most important thing is that we tell it that it's got anatomy and that there are artificial teeth. Okay. The second step here is that we want to tell it that it has gingiva. Okay. Now it will default to this first one, which is dentures gingiva, which is what we want. And if we hover over the plus sign, we can change the material here to VITA Bionic Base. And that's going to select a few presets in the software for us, and I'll show you what that looks like a little later on. Again, you can select the color if you're going to use this as communication with your lab or clinician. The important part here is this type. Okay, there are a few different options here. And usually what comes up first is this monoblock. And if we select monoblock, what will happen is that when we get done with our digital design, it is going to output an STL file for just that monoblock. Okay? That what we want to select, though, instead is this base with artificial teeth manual reduction. Okay, and I have mine set as default, and you can go ahead and do that. It's up to you, but this is the one we want to select, this artificial base with artificial teeth. Okay, and the reason for that is that when we select that, when we get done designing, it will output both an STL file for that monoblock try-in and an STL file for that base with the tooth pockets. Okay, that way, if everything goes well during the try-in, we can go directly to manufacturing the final without having to go back into the software and do any kind of redesign or anything like that. So that's what we want to make sure that we check, is that under the type, that base with artificial teeth. And finally, the manufacturing process. There's two options here. There's milling and there's printing. And it's exactly what it sounds like. It totally depends on how you're planning to manufacture this. And what it does is it will select a few presets in the manufacturing software. I will show you what that looks like when we get a little further in the design. And so again, depending on whether you're milling or printing, you're going to select that. Once you've got that selected, you can, if you're using a desktop scanner and you're scanning a cast, you can hit scan and that will launch your scanning software. If you're using an intraoral scan that you got from your clinician, you can simply say OK, and that will create the order, and then we can import it. Okay, and I'll show you how to do that in just a minute. Let's jump over to the exocad and set up the order there. So in exocad, we want to select new. It'll give us a new order form. The client, the technician, those are up to you. How you name this is up to you. Again, with the software, when we're setting it up, we want to make sure that we include second molar to second molar. Okay, so we're going to select that second molar, and it's going to give us the options over here. And we're going to tell it full denture. Now, again, like we talked about in the 3Shape, depending on how you're planning to manufacture this is going to dictate what selection you choose. So if you're planning to mill this, you're going to select mill base. If you're planning to print this, you're going to do print base. And both of these are 4 carded teeth, which is what the VIGO teeth are. So it's up to you guys. It totally depends on how you're doing it. And then for options and parameters here, and this is the same for the 3Shape. If you guys have a pre-op model or an existing denture, you can scan that as a reference also. At the very minimum, you're going to need both arches and a bite rim. So bite rim scan, yes. Design with scalable tooth libraries, and it says no. And that's what we want because, again, we're using carded teeth, so we can't scale the tooth libraries. Design prosthesis with monoblock try-in and optimize monoblock for 3D printing. On both of these, I typically say yes. And the reason is because it will give me the option later on if I change my mind, but this way at least I've got it. I've said yes. If I decide no later on, that's easy, but at least this way I've got it. Okay. And optimize for 3D printing. Almost everybody 3D prints their monoblocks. It's just the most practical way to do it. So I always say yes on that one. The last thing we want to check here is this tooth pocket gap. It should be set at 20 microns, which is 0.02, which is what mine has right down here. If it doesn't say that, that's what you need to set it. And I will say okay. And we'll talk a little bit more about that tooth pocket gap a little later on when we get in the design. Again, it's second molar to second molar. If I hold shift, click that, it will select all the ones in between. We're the same thing on the lower. It's going to give us this option here, full denture. It should have saved all of our selections for the upper, so we just need to say yes. Select the other side. Tooth shade, again, if you're communicating with your clinician or your laboratory, you can add that. Scan mode, again, if you're doing desktop scan or intraoral scan, I'm going to say digital impression because that's what we have today. And then I can say save. And again, if you're using the desktop scan, you can go into the scanning software and scan it. If you're using an intraoral scan, go to the design, and it will let you import it. All right, so it's going to launch that. I'm actually going to pause for a second and go back to 3Shape. And for those of you following along with that 3Shape, let's import our scan. So if you right-click on the order that we made, you can either scan if you're using the desktop scanner or import scan if you're using the intraoral scans. And if you go to that flash drive, you should have the scan files here. Jaw, upper jaw, max rim. These should be exactly the same as ones that I sent you guys. There we go. Should look something like that. Okay. So once we have our information in there, and really this is the most critical part of this entire process, is our records. That if you guys have any experience with computers or digital technology, whether it's in dental or not, you know that with computers, the result that we get is only as good as the information that we provide it, which is why the record keeping step of this is the absolute most important. So whether you're taking traditional impressions and pouring up a cast, or you're taking intraoral impressions, you need to make sure that they are complete and accurate, especially when we're using the computer, because if it's not, the computer will simply say no, and you're going to end up having to call your patient back and take new records and all of that. So please spend the time, take good records, make good impressions, make sure that they are complete and accurate. It will make or break this entire workflow. Okay. So once we have it in there, the first thing that it is going to ask us to do is our model analysis. And the model analysis is essentially identifying some certain landmarks and characteristic points. A lot of it is stuff that we would or should normally do on any denture case, whether it's analog or digital. Okay. The first one is we're going to define our occlusal plane. And so it says place 3 points. 1, 2, 3. And we're going to get our plane of occlusion. And again, if we've taken good and accurate records, this should be very easy. We can line up our midline, we can line up our plane of occlusion, get our teeth roughly in the area we need to, and say next. Turn this off. And next it's going to ask us to identify some characteristic points. So our tuberosity, incisive papilla, their tuberosity, our two canine points, and on the lower, our tremolar pad, buccolingual, central ridge point. Now, one of the questions that I get a lot on this is, how important is this step? And what I usually tell people is, it's important, and it's important that you be as accurate as you can be, but at the same time, it's not super critical that, if I don't get this canine point in exactly the right spot, okay, the difference it's going to make later on during the design is not as significant as you would think. Okay, so one of the big advantages of doing this digitally is the amount of time that we can save during the process or the workflow. And this is a good place for that. Okay, it's important that you get these characteristic points in there and get them in there as accurate as possible, but at the same time, don't spend a lot of time agonizing whether or not they're in exactly the right spot. Get them in there, get them close, and that's good enough. Don't spend a whole lot of time. If you're spending more than 10 minutes here doing this, you're spending way too much time. Okay, get them in there, say next, and now it's going to ask us to define or outline our denture here. Now, this usually varies depending on the technician. Some people, everybody likes to put their spline in a slightly different place, and depending on the patient or the particular case needs, you can vary it however you want. And that's totally up to you. 3Shape actually gives you a chance to change this or modify it one more time before you finally finish it. You can always move these points if you need to, but essentially that's that step. Then I'm going to do the same thing on the lower. Just going to mark our boundary. And I tell people, if you get one of these in the wrong spot when you're putting it in, don't stress on it. Don't try to fix it. Just get that spline in there and then go back and fix it. It gets difficult to work with if you try and go back and fix it before you have a complete spline. It's much easier to just go back in and move your points after you've got it in there. And you can either move it individual points like that, or you can do fast edit spline and you can draw it in like that. Okay, so there's a couple ways to do that. Next, and the next thing it is going to ask us for here is to set our path of insertion or surveying blockout, however you guys are used to looking at this. So the default, and this will probably depend on how it's scanned in, but the default is going to be this blue line here. And it will show you your undercut areas and how deep your undercut areas are. And there's a couple of ways to change that depending on how you want to adjust your block out. You can either use these arrows here and you can move it a specific amount in the different directions, or you can actually turn it and eyeball it and then say set from view. And it will change that post to look straight down from where you're looking, and it will block out your undercuts. Okay. And say next, and it will take us to the wax trimming. So depending on how much retention you want or don't want, is totally up to you. You can add or you can remove the blockout wax here depending on what your needs are. Okay. Same thing on the lower. Say okay and hit next. I'm going to leave it blocked out. And before we get into the teeth, I'm going to jump over here to Exocad, and we're going to do the same thing. Let's import our scans, and we'll go through the model analysis. Okay. So you can either load or it will jump up here and prompt you. Here is our scans. Again, they'll be on the USB drive that I sent you for jaw, lower jaw, and wax rim. And these are the same scans that we used in 3Shape, so they work for either the 3Shape or Exocad, so you can use them for either one. And here we go. So there we go. So model and our bite scan. This is next to start the model analysis. Now it has full model analysis and basic model analysis. I've used it both ways. I have not noticed that doing the full model analysis makes any more of a difference or enough of a difference to make it worth the extra time. So I almost always use the basic model analysis. Okay. And again, just like we did before, the first thing it's going to ask us is define our occlusal plane. We're going to define it by 3 points: left, right, and center. Apply, and there's our plane of occlusion. Next, our incisive papilla. So you can see that a lot of these steps are exactly the same between the two softwares. Okay. Lateral position, premolar position, premolar pads. Now this one I usually have to change to get it up on the ridge here. Like the way that looks better. Next, it's going to select those for me. Sure, that's fine. Okay. And that is the basic model analysis. Okay. And again, it brings us to the tooth setup. Okay, so that is importing and the model analysis for both of the softwares. Before we actually get into the teeth selection part of this here, I'm actually going to jump over here and show a couple of slides. Okay, so this is really where the biggest difference in this workflow comes out, is the actual tooth library that we're using is what's going to make the difference, and I'll show you why. Okay, and the first thing is that the VIGO tooth library was designed specifically for digital dentures and digital manufacturing. Okay, that the problem with your standard carded teeth is that they've got these very long necks and they've got the undercuts, built into them, both of which don't lend themselves very well to digital manufacturing. So eliminated how we changed the design. We reduced the base, we reduced that long neck, and we optimized that surface area for gluing. Okay. We made it so that you can adapt those tissue margins depending on your patient's needs or the individual situation. Also, we changed the contour a little bit between the teeth for that manufacturing that papilla. If you guys have done any of these teeth digitally before, you'll know that those tooth pockets and those papillas come out very thin and almost razor sharp, and they're very easy to chip and break. And again, the advantage of doing this digitally is it saves us a lot of time, and we don't want to waste time having to go back in and fix or repair or replace those papillas that didn't come out well. So we recontoured it so those come out a lot more natural looking, much easier for the manufacturing process, and less post-processing work. They're a tapered oval, so they fit passively. There's no undercuts. They're 100% accurate, so you can't get them in the wrong way. They only go in one way. There's no rotation. There's no wiggling, and I'll show you that when we get to it. If you guys are familiar with our teeth, our Lingoform and our Excel, which is one of our premium lines of teeth, these are actually based on those teeth. So the anatomy actually looks very, very similar to the Excel and Lingoforms if you're used to that. Okay. Again, there's no undercuts. It's designed for digital manufacturing. But at the end of the day, it is still a true denture tooth. Okay, that you've got that really nice layering, you've got that surface texture, you've got that translucency, you've got that body and incisal, you've got that fluorescence, opalescence. None of those things you're going to get from a milled or printed tooth. Okay, so we're talking really nice teeth, really nice aesthetics, very well made. They're silicate microfiller reinforced SE polymer, which is a bunch of fancy words that basically means it's very hard and has a very low abrasion rate. Okay. And here's one of the really cool parts about this specific tooth library is not only did we put the teeth in the library, the shapes of the teeth in the library, but we also put them in, they come pre-set up. So we've already done the occlusal setups for you. Again, we're trying to save a lot of time. And so to have these, preset for you, you can get it buccal, lingual, crossbite, Professor Gerber, and you can mix and match any way you need to, for over 600 different combinations. So whatever your clinical situation is, there should be a combination to fit. And again, we'll talk a little bit more about those presets or the setups when we get into the design part, and I'll show you what that looks like. And again, for more information, our socials, and then if you guys got questions, we'll come back to that later, but let's get into the actual tooth selection and design. Okay, 3Shape, here we go. Now, even though we told the software during the order form setup that we were going to use the VIGO teeth, for whatever reason, it is not connected to this part of the software, so we need to, again, tell it that we're going to use the VITA teeth. That usually defaults to the Candelure, which come as part, in the software already, preloaded. So in this drop down here, I'm going to select VITA, and it is now going to give me my VITA library. Now, in selecting this, I have some other videos on our YouTube page, so if you guys want to check that out later on how to select the correct teeth, that really the same as you would select a set of teeth for any denture that you're doing. Most of the time, the clinician will select it for you. If the clinician does not, at the very least, we should have, our plane of occlusion, our midline, our canine points, and our smile line in there. And from there, we can usually determine, what we need. The way we have this divided out here is ovoid, triangular, rectangular. And for this particular set, I'm going to use the triangular, drop down here, the T48. And if you notice, it will select the lower and the posteriors that correspond with those anteriors according to the mold chart or the combination chart. Okay, again, that'll save you time, energy, makes it very streamlined, easy to do. If for whatever reason you do not want to use the combination chart, you decide, oh, this one's a little weird, these lowers, I want them to be a little bit bigger, you simply uncheck use combination chart, and then you can select whichever mold that you want. Okay, and you can mix and match this however you need to for whatever your specific scenario is. Same with the posteriors here. Again, they come pre-set up. You can either do buccal, lingual, Gerber, crossbite, and you can see that it mirrors it on the other side. If for whatever reason I didn't want that, I can use, it's checked here, use single posterior library, uncheck that, and I can do one side buccal and one side crossbite. Why you would want to do that, I have no idea, but it is available if you should choose. I am going to set it to lingual because that's what I'm probably the most commonly used, and I am going to say apply. And it is going to take that tooth library that we selected, and it is going to insert it here into our arch. And we can take a look at it. If we like it, cool. We can also move it slightly if we need to. I know this one fits because this is the one that I use for this, so we're okay. Though, during your selection, if you decide, oh man, maybe I don't want that one, again, you can always choose something different, hit apply, and try a different tooth library. Okay. We say next. And I'll talk a little bit about this when we get into our, get on the bench. Oops, sorry, I got ahead of myself. We're actually not going to say next yet. That all the design or movement of the teeth is actually done here. So the first one is our global transformation tool. So this, like I showed before, will move all of the teeth together as a group. And then we've got our individual transformation tool and our group tool. Now, like I said, these teeth come in perfect occlusion. So you can see here, these posterior teeth are all in perfect occlusion, which means if I do absolutely nothing, and I leave this set up exactly the way it comes in, when I finish making this denture and I put it on an articulator, I will have perfect functional movement in all of my excursive movements, okay? Which is awesome. Again, this is saving us a ton of time when it comes to the actual denture setup, okay? So because these come in perfect occlusion, I encourage people not to move them, all right? That with our individual transformation tool, if we, don't want this to be too perfect, I can usually go in here in the anterior, and I can move, some of these anterior teeth, maybe flare these anteriors here, or something like that. So I can individualize it, I can characterize it however I want, but that's not going to interfere with the actual function or occlusion of it. Okay, so I can still individualize it without messing a whole lot with those posterior teeth. But if we need to move these posterior teeth, we can use this group function tool and move them as a group. So say I want this a little more over the crest of the ridge. See, I can actually rotate this out a little bit, but you can see it moves them all together as a group, which doesn't change the actual occlusion or function. Again, I tell people, don't move these, especially these posteriors. Once you start moving them individually, then that throws your occlusion off, and you're going to end up having to regrind in your occlusion later on. Okay, so, and especially since we're doing a full upper over a full lower, there shouldn't be any reason to move those posteriors a whole lot. Save yourself the time, take the advantage, and use those pre-setups. Okay, and yeah, so let me show you how to do that in exocad. Okay, so in exocad here, we're at the tooth placement. So same thing, this is it's laid out a little bit different, but we're going to do it the same way. We're going to start with those upper anteriors, and if we scroll all the way to the bottom, because they're in alphabetical order, I'm going to do the T48. Okay, that is the triangular 48, and it will automatically select that L37, which is the lower that goes with it, although you can always change it if you need to. This one isn't going to automatically select the posterior, so you're going to have to select those according to the mold chart, which is on this particular one, the 22L lingualized. Now here it says placement of second molar. If possible, always or never. Now this is totally going to be a personal preference, and it's going to depend on the case. I either do if possible or always. And the reason is it's pretty easy to get rid of those second molars, but it's a little harder to bring them back if I don't have them. So I usually will say if possible or always, so that I always start with them, and then I can get rid of them if I don't need them. Okay. I'm going to place the anteriors. I'm going to place the posteriors. And it is going to set the teeth for us. Now, in exocad, to be able to move the teeth around, we actually have to hit next. And go to the next screen. So there's a couple of ways to do this here. And the idea is the same as before, that we don't want to use, or we don't want to move those posteriors, or we want to move them as little as possible. Again, because they come in perfect occlusion. If I go to rotate and chain mode, again, it will keep these all together as a group. So it's not going to change my occlusion or function, but I can get this over the crest of the ridge if I need to, or I can move them out, whatever I need to do with those posteriors. Okay. The anteriors, and I'm going to change it to move. Again, if I keep it in chain mode, what's cool here is that I can move these, and it will keep them in contact. So that way I don't risk having open contacts. It's always going to keep those proximal contacts together. So it makes it pretty easy when you're going through and doing these setups. Of course, you can always go in and move a single tooth individually or rotate it. So if you want to do some individual characterizations, again, so it's not too perfect, it's not going to change our posterior occlusion. It's still going to function correctly, but it's going to look nice and aesthetic. All right. And that is how to set up the teeth in exocad. All right. So that, for the most part, is the tooth setup. The final part of this is our pre-manufacturing. And I talked about some of the presets that we selected when we set up the order form and how they affect this. And I will show you what that looks like here during the pre-manufacturing. So we're back in 3Shape. Okay. And we've got our denture-based design. So after our smile composer, again, I told you that it would give us one more chance to change this base design if we need to. So this is it. And it's going to give us some options here. Okay, no, thank you. If you need to add additional blockout or a window or something like that, you can change your base thickness settings. Although, depending on the material you're using and how you're manufacturing it, I would not go too thin here. Be very careful with that. This is one of those options I was talking about. If you upgrade to version 2020 of the 3Shape software, this gingiva aesthetics is one of the new features that it added that, again, is specific to dentures. It's pretty cool. It's kind of a, for doing your festooning and characterization of your gingiva, it's kind of a preset. It kind of gets you part of the way there. I like this one, Intense, but you can play with it. And then the final part here is the manufacturing settings. Okay, remember when I said when we're setting up the order form that we could select either milling or printing depending on how we were planning to manufacture this. Okay, if you are milling, you would select milling, and then it will automatically check this box here. Okay, and this is our drill compensation. So basically, it's going to take into account the size of the burrs that you're using in your machine. Now, one of the really cool things about the VIGO teeth here, when I was talking about, we designed them specifically for digital manufacturing, is that the shape of the bottom of those teeth to make those tooth pockets, we designed them in such a way that you can mill that entire base, including those tooth pockets, with a 2mm burr. Which, when it comes to manufacturing, that's really cool. It means that we don't have to waste a lot of time changing burrs or using very small burrs because they wear out quickly and it takes time. That we're able to do everything with a 2mm burr, which is really cool. Of course, you can use smaller burrs, but depending on which tool you're using, you can set that here and it will calculate it based on that. So if you're milling, say milling, and it will select this drill compensation. If you're printing, select printing, and it will automatically uncheck that and turn that off. Okay? Let's say next, drill-based compensation, because we select milling, yes. And it is going to calculate that base for us. And this is one of those steps that takes a little bit of time. pretty much no matter how fast you get at this. It's all software. Depending on your computer too. Sometimes this can be faster or slower. And almost there. This gingiva aesthetics is pretty cool. I'll show you what it looks like when we get there. Again, here's our lower. Same thing, we can modify this if we need to. We can change our settings. I'm going to say intense just for fun. And it's going to calculate the lower. And again, on this base thickness, I probably wouldn't go any thinner than the default 1.5. A lot of people actually turn that up to 2 millimeters, depending. Just want to make sure that you don't go too thin, because no matter what material you're using, how good it is, if you get that base too thin, it's definitely going to break if you're not careful. And there we go. So you can see that it kind of started with that festooning, and it gave us kind of a good place to start. And again, one of the advantages to doing this is the amount of time that you're going to save. The amount of time that you're going to save, we don't want to waste a whole lot of time. So if we select that preset for that gingiva, that'll get us, halfway there. I don't have to go back in, but essentially it gives us our sculpt toolkit. If you guys have ever used 3Shape before, this is the same as in their other modules. Essentially, you've got your wax on, wax off, your wax knife, you've got your morphing tool, and you can adjust this however you want. If we have some time, I'll go through one. This is one that I did earlier, just to kind of show you guys, what you can make it look like. Now, this is really kind of depends on, again, this is a personal preference. I prefer to do all of my festooning and characterization of the gingiva in the software itself. So that way, after I'm done manufacturing it, I don't have to go back in and do a lot of grinding on the bench. Again, I'm trying to save a lot of time. Some people are more comfortable with that, so they'll grind it in later on. That's a personal preference. It's totally up to you. The other thing that I found too is depending on how you're manufacturing it, whether you're printing it or milling it, you may have to adjust the severity of your festooning. I've noticed that if I'm milling this, that I actually have to go back in and make those a little bit deeper and a little bit more severe because of the geometry and angulation of the mill. It gets kind of muted. So you'll have to play with that and try it out and to kind of dial it into how you like it personally. In ExoCAD, what does that look like? All right, we've set up our teeth. I'll say next. Say next. All right. And so some of these steps in ExoCAD, these are the same steps that we did in 3Shape. We're just doing them in a different order. In 3Shape, we did our insertion direction and blocking out before we set our teeth. In ExoCAD, we do it after. So here is our insertion direction and our block out. Again, you can change your offset, the angle, how much retention you want in there. This also has here in this step our pre-manufacturing. So like we were talking about with the 3-shape, your drill radius or your burr diameter, you can enter that information in here as well. Okay, if you want to change your path of insertion, you can do like we did before on the other one and set from view. If you like where it's at, you can simply hit next and move on to the lower arch. So again, all of these steps are exactly the same between the two softwares. There's just a couple of them that are in a different order. Here's the lower. Again, I can change my offset, my angle, how much undercut, how much retention. And then if I'm going to mill, I can put my milling information in there as well. And it's going to calculate the base. Now in the 3-shape software, it asks us to outline or define our base of our denture in the beginning with our model analysis. And then it gave us the opportunity to modify it later on. In ExoCAD, it doesn't allow us or ask us to set this until here at the end. So it's just this one time, but same thing, put your spline in there. You can always adjust your points and move them around to where you like them. So if you need to move them, you can always move them. Say next, and it'll ask us to do the same thing on the lower. Again, I usually tell people just get that spline in there, get it connected, and then go back and move or modify, adjust your points to adjust it. If you get one in the wrong spot, don't worry about it. Wait till you've got it in there, then go back and fix it. If you try and fix it before you've got a complete spline in there, it gets wonky. For those of you who've worked with the software before, you know. And again, depending on computer you're running on, this is a step that takes a while to calculate. And almost, you can do it. And here we go. And we'll do the same thing on the lower. There's our gingiva. And let's set our border for our lower here. Okay. Again, you can set this wherever it makes you happy. Let's get it in there. And we can always go back in and move it or edit it if we need to. And again, we'll say next. We'll wait a really long time while it calculates. For being a digital person, this is the most difficult part for me. It's having to wait.
So, Paul?
Yes.
Couple questions here while we're waiting for it to load. One is, can a single arch be printed milled using the VIGO teeth?
Currently the approved workflow is a full upper over a full lower. And the reason is because we're using carded teeth, and there's no way in the software to modify or adjust the occlusion of those teeth to natural dentition. The short answer is yes, the software will allow you to set it up as a single arch, but again, because it's pre-carded teeth and there's no way to adjust that occlusion, that if you do a single arch over natural dentition, you will have to grind in the occlusion by hand after you're done, with the denture. So it's not the approved workflow. It's we're trying to find a better solution to the single arches. So that's why it's not currently in there. So is it possible?
Right,
yes, it's possible, but it's kind of a workaround. If you want to know more about that, call me or email me and we can talk about it more.
All right, thank you. I see it's loaded, so I'll let you go back to it.
Okay, so it's loaded our gingiva here, and again, it gives us our wax tool so we can go in and adjust or modify. One of the things I like to do is if we right click over to the visual properties, turn off the color. For me, it makes it easier to see. I still don't like the yellow. I wish they would make it pink, but again, you can go in and modify and edit it. Here's one that I started earlier this morning. And again, depending on whether you're milling or printing these, kind of the severity of your festooning there, you may have to adjust it a little bit. Okay. And I'm going to say okay for this particular one. And because I want to show you, again, the pre-manufacturing for the ExoCAD. And minimum thickness tooth pocket gap here, again, should be set at 0.02 or 20 microns. Again, it gives you the option here if you're going to mill it, if you need to compensate for the milling. It is going to cut that denture base to fit that model, and it's going to adapt that gingiva to the teeth. And then it's going to give us a couple more options. Like we talked about before during the setup, the option whether we want the monoblock try-in, whether we're going to print that. Like I said, I always say yes, just so I have the option. If I choose later on not to use it, I don't have to. But that should be what it asks us to do next. It's going to ask us to do the lower first. Okay, lower. There we go. Calculate. Again, if we've got more time, I'll go back in and show you how I festoon these digitally. It's totally, again, a personal preference. I more or less have adapted, some of the bench techniques that I learned doing dentures and do it the same way digitally. Some of them work, some of them don't. That's just a learning curve. You're just going to have to try it out and see. I do like the presets, like on the 3Shape. That saves me a lot of time. I know that I talk a lot about, saving time, during the setup and in the software here. The one place I usually will take the time is during the step of the characterization and festooning. Again, because I don't want to have to do that afterwards. I want to be able to just, take it off the machine, give it a polish, and not have to grind on it a whole lot. So I usually spend a little extra time on that part of it. So here, generate and save monoblock try-in, continue without monoblock try-in, and optimize for 3D printing. So again, like I said, it gives us the option here. At least it's here. If I choose not to use it, that's easy. But if I do want it, I can simply go next. All right. And that, for the most part, is how to do a design in the software for a digital denture. Now I'm going to switch over to the bench, and we're going to talk about, we're going to do some more hands-on stuff. So one of the questions that I usually get about now is the question, okay, hey, this looks really cool. I really like this, but I don't have the software yet. Can I still do digital dentures? And the answer is yes, absolutely. Okay, that we did our best to make this as versatile as possible, so that no matter what your level of technology or equipment is, that you can still take advantage of the digital workflow. That VITA has partnered with several different people like Edge, who does the digital design. So if you want to do digital dentures and you say, oh, I have a printer, I have a mill, but I don't have the software yet, then you can simply take your model or your intraoral scan and you can send it to a company like Edge, and they will do the design just like I just demoed for you, and then they will send that back to you. And that's all they do, is just the digital design. And for some people, that works out great. They say, I don't have to buy the software, I can have them design it, and then I'm going to manufacture it myself because I have a printer or mill. Or if you have the software but you don't have a printer or mill, again, not a problem. We have partnerships with a company like Core3D, which is a big manufacturing center, that all of the bases that we're using today in this workshop, Core3D printed for us. And so, if you want to do the design but you don't have, or you don't want to do the manufacturing yourself, you can outsource that to a place like Core3D, and they will print the bases for you. And then you would get, essentially like you got today, a denture in a box, which you would get the printed base, you've got the VIGO teeth, the bond kit, and I will show you how to finish or finalize a digital denture. So again, depending on your level of technology and equipment, there's all kinds of options. And there's some more information about our partnerships on that USB that I sent you guys. So you can check that out if you have more questions about that. Your kit. In your kit, you should have a base with tooth pockets. You should have a set of VIGO teeth. You should have a bond kit, which comes with a 2-part liquid bond. You should have a couple of tubes of our VMLC, okay, our window and our gingiva. And I think that's everything that comes in the kit. All right, so where do we start here? Okay, so this is the way the base is going to come. If you're printing it yourself or if you're outsourcing it, this is usually how it's going to come off of the printer or after it's been cured. Okay, we've got our support bars here, okay, to make sure that we ensure the dimensional stability as it's being printed. You can see here, focus at the the leftover support bars here on the facial, okay, from where it was attached to the print platform. Okay, so what we need to do to prepare this base is we need to cut off these supports. We need to smooth out where these supports were, and we need to sandblast these tooth pockets. Okay, when we're sandblasting these tooth pockets, we want to use 50 micron aluminum oxide at 2.5 bar pressure. And then I usually steam clean it when I get done. That the teeth, the VIGO teeth, come in the blister pack pre-sandblasted and pre-cleaned. Okay, so they're ready to glue in. We just need to do the same thing to the base. So here's a base that I did that to. You can see I cut off the support bars. I smoothed out where the support bars for the print plate were. And if you can see, I have sandblasted these tooth pockets. The other thing that you'll probably notice too is I've actually already given it a little bit of a polish. Okay, and this is totally a personal preference. You can polish it after the teeth are in, like you would normally polish a denture, or you can polish it like I did before. And the reason that I polish it before is because I really like the texture on the facial of these teeth, and I don't want to risk polishing them off. And so I will actually polish this base before and then glue in the teeth so I don't risk polishing that off. Okay. But again, it's totally a personal preference. You can do it either way. For our teeth, and here's one that I started earlier. And what I like to do is when I pull the teeth out of the package, I like to lay them out so I know where they are. They're easy to get at. And then I usually will just do a quick test fit. Now remember, I've talked about this several times, and that the tooth pocket gap that we're using is a 20 micron tooth pocket gap. That's 0.02, and this is what that looks like. Okay, that when I put this tooth into this tooth pocket here, you guys can see that it fits perfectly. That there's no gaps anywhere around. There's no rotation. There's no wiggling. There's no movement. That is what a 20 micron gap looks like. Now, why is that so important? Again, I talked about this a lot when we were looking at the teeth in the software, that those teeth come in perfect occlusion. Okay, that I spend all that time setting up those teeth in the software, that if I cannot translate that perfect occlusion from the software to my final prosthesis, then I'm wasting my time. Okay, so having a 20 micron tooth gap ensures that these teeth are going to end up exactly where I planned them in the software. Okay, so that's why it is so important. Now, how is it that we're able to use such a small tooth gap? Okay, the reason is that we're using our bionic bond system. Okay, that if you guys have seen any of the other digital denture workflows out there, most of them are using an uncured resin as their bonding agent. And the problem is that uncured resin is so thick, it's so viscous, that it requires 170 or 150 to 170 micron gap to be able to use it. Now, that gap is so big that it leaves too much room for tooth movement. So people are having to use jigs and putty and matrices and stuff to hold the teeth in position while it's being cured so that the teeth don't move. Okay. And our Vionic bond is a 2-part liquid bond. So part 1 and part 2. And I'm going to pour this in here. And I am going to stir it up. Now the difference with our bond is very, very thin. It's very low viscosity. It's almost like water. Okay. And because it's so thin and low viscosity, that's how we're able to do that 20 micron tooth gap. Okay. So, and again, that ensures that our design is exactly how it is on the screen, is how it's going to be when we're done with our final prosthesis, that we want to ensure that accuracy when we're manufacturing. So once I have mixed this, it has about a 10-minute working time, which means that there's enough time to do a full upper and full lower, but there's not a lot of time to lollygag. Okay. That what I want to do is I want to get, so this is the brush that it comes with, just a little tiny brush. Just going to dab it in there, wipe off any excess, and I just want to wet this tooth pocket. Make sure you guys can see this here. So I just want to wet that tooth pocket. Okay, I don't want it to pool. I don't want any excess. Okay, it's not meant to be gap filling. You guys saw how well that fit. I'm also going to wet or paint a layer on the tooth itself. And then I'm going to put it in there. And I'm going to hold it down firmly for about 8 to 10 seconds. Okay. Now again, this only has about a 10-minute working time. So while I'm holding this one, I'm going to start moving on to the next one and make sure that I move through this fairly quickly. And by the time I've got that one painted, it should have been held down enough. And I can move on to the next tooth. All right. And that is how you glue in the teeth using the Vionic bond. Now, I typically start at the back and I just work my way all the way across the arch to the other side. For today, I started with that first molar because it's big and it's easy to see and it works really well for demos. But to be, like I said, in the interest of time, I usually just start at one side and work my way across and then again to the lower. Now, the Vionic bond, this kit, this 2-part kit that we've got, okay, one kit is good for a full upper and a full lower. So a total of 28 teeth. Again, the workflow is a full upper over full lower, so one kit is good for that full upper, full lower, 28 teeth. Now, once you've got those teeth bonded in, this is an auto polymerizing bond, which means if I do absolutely nothing and I leave this sitting on my bench, it will fully cure within 12 hours. Okay. Now I can speed that up by putting it in the pressure pot for about 20 minutes at 55 degrees Celsius at between 2 and 3 bar. Okay, so about 20 minutes in the pressure pot or 12 hours on the bench, and that will cure that Vionic bond. Okay. Now, if you guys have used other workflows before, if you've used the resin workflow, the biggest difference between this and that is that when the base should be fully cured on the printing curing unit before you glue those teeth in. That this should never go back into that base curing unit. Okay, the printing base curing units have both light and heat that cure that material. Okay, and that is not compatible with our bond. Okay, that I'll demo here our VMLC, which is our light cure composite, in a minute, and that is strictly light cure. That can't go back into the printed base curing unit either. Again, because it includes heat along with the light cure. So these bases should be fully cured before you glue in the teeth. Once you've glued in the teeth, you can either let it sit on your bench for 12 hours or you can put it in the pressure pot for about 20 minutes. Once you have your teeth bonded in and it's gone in the pressure pot or it's fully cured, then we can characterize it with some of our VMLC. Let me show you what that looks like. Okay, so we've got our gingiva, we've got our window, and we've got some modeling liquid here. And I'm going to put a little bit of this out here. There's a gingiva, the window, and a little bit of our modeling liquid. Now, our gingiva actually comes in 5 gingiva colors. So depending on what you need, you can get it in 5 gingiva colors. And we also have a paint kit for adding some different characterizations and stuff. So if this was an immediate denture, so this is where it kind of gets into how you're going to, sell or how you're going to, produce these digital dentures. And you can kind of vary it depending on the type of denture you're going to produce. If this was an immediate denture that was only going to be in the mouth for a very short time, I would probably polish it, glue in the teeth, and send it out the door, and that is it. I wouldn't spend any more time on it. Again, we're trying to save as much time and labor as we can on this. If this is a definitive denture, I would probably go one extra step and I would add some of this VMLC window. And what I would do with it is, let's see if you can see here, is go into the interproximal. And if you get a little bit of the modeling liquid and some of this window, which is clear, and we drop a little bit right there into that interproximal, it should just wick right in and seal the interproximal here of this between these denture teeth. That way, your patient doesn't have to floss their denture. So any definitive denture, that is kind of the minimum set extra step that I will take, is I will put a little bit of this VMLC window in the interproximal there. Now I can do the same thing, of course, with the pink. So if I find that I've got, a little sliver or micro gap somewhere, I can add it to the gingiva. Or however I want to mix and match it. Now, like I said, it comes in 5 gingiva colors and we've got an entire paint kit. So if you have a very high-end denture that you're making, you can spend a little more time with the VMLC and do more characterization. This is one I worked on earlier. I actually have 3 different colors of the VMLC gingiva on here. I used our paint kit and I put a little blue and a little purple in here for veins. I got a little red for capillaries. I mean, you can really go to town on, how fancy or aesthetic you want to make these dentures. Okay, so it's really up to you. The one thing I didn't talk about yet, which I said I was going to, was there was that message talking about the noising on the teeth and the monoblock Trian. So this is a printed monoblock Trian, okay? And what that message says and is telling us essentially is that for these monoblocks, because VITA doesn't want people to be able to reproduce their teeth, they've added noise to this teeth so you can't individually reproduce them. But what I've found is that when you're printing these, and again, printing is just the most practical way to do it. It's the cheapest, most cost-effective and time way to make these monoblock Trians. Is that once they've printed, just like this denture base, the little bit of texture that we have from the support sprues, that is almost exactly what the noising of the teeth looks like. So when I give this a quick polish, most of that noising on the teeth comes right off and it looks just like that. So don't let that message telling you that the noising on the teeth bother you. It's really not as big an issue. And as we add more features and availability and workflow options in the software, I think that some of those things will change also. But that is what a printed monoblock should look like. You can see that it looks identical to the final. On these monoblock Trians, if you want pink, it's actually very easy to add a little bit of the pink composite here, or even just a little bit of pink wax if your clinician or your patient really likes the pink and doesn't like the white. There's a couple options there. The other thing you can do too is, I talked about polishing, and let me see if I can show you guys this here. See if we can focus that in. If you guys can see the texture on that teeth. Now, I really like the anatomy, the texture on these teeth here. So I try and keep it. Some people don't like that much texture. So it's actually very easy to get rid of it. As you can see here, this side has no texture. All I did is hit that with the polishing wheel, probably 3 to 5 seconds, and that'll get rid of most of your texture. So you can modify these teeth, again, to fit whatever your patient needs and the aesthetic or look that you're going for. Like I said, I like the texture, so I pre-polish it so don't lose it, or you can polish it after and get rid of that texture. So there's all kinds of different options. I think the one thing I didn't show you, if you're milling it, it should come out of the mill looking something like that. And again, I don't know if you can see real well in there because it's kind of deep, but I've got all that festooning and texture on there. All I have to do with that is cut off these support sprues and polish it, and it's good to go. So that, for the most part, is a good introduction on digital dentures. So let's go to questions. Jim? How are we doing there, Jim? Do we have some
All
questions?
right. Yeah, Paul. So we got a couple questions here. On the design, how much release space do you recommend on the base for saliva, although I'm not sure there's a lot of saliva caught in between. These are pretty intimately fitting, but
yeah, the default I think is 0.15. That's what I usually just use whatever the default is. It's usually fine. You can adjust it if you need to, but I wouldn't go too crazy on it.
All right, and then during your model analysis, do you sometimes leave slight undercuts in the design?
It's totally a personal preference, and it really depends on the case. It depends on how much retention I need, how much retention is available. Yeah, there's a lot of factors that go into it. Typically, I don't leave a lot of undercuts. That one of the things that I've found with the digital process, especially if you are doing intraoral scanning, that the information is very, very accurate. So the seal and suction that I get from most of these dentures is really good. So I don't need much undercuts for retention and that kind of stuff. That usually they fit pretty exceptionally. You guys will also notice that I didn't put a post-palatal seal in this denture. That there is no function in the software to do that. That if you want one in there, you would actually have to carve it in the model before you scanned it. But again, in my experience, I've actually found that I don't need a post-palatal seal because the information I'm working with is so accurate, and the manufacturing process is different than the way we've done it in the past. And so there's a lot fewer discrepancies that we have to compensate for. And that's one of them. So
I'm glad you mentioned that. That was a follow-up question.
Okay. To whoever was asking about the relief, like I said, the default here is 0.15. That's what I usually use. I haven't found any need to change that.
All right. Do you primarily use the chain mode or the single tooth to reposition the teeth?
Yeah, so I almost exclusively use the chain mode. And again, the reason is that way I don't have to worry about leaving any that way I don't get any of the teeth too close together so they're not penetrating each other, or I don't get them too far apart so that there's a gap. It keeps all of those proximal contacts in contact no matter where I move them. So it makes, again, that designing process, it saves me a bunch of time. So unless I'm going for a very specific characterization, like I said, like I want to flare a couple of the centrals or do something specific, that's about the only time I'll use the individual tool.
All right. So I'll tie a couple of questions up about the bonder. Does the bonder require light curing, and do you have to take time to clean off any bonder? So the Vionic bond, the adhesive.
Okay, yeah. So good questions. So the Vionic bond is an autopolymerizing bond, which means that, again, if I do absolutely nothing, it will fully cure sitting on my bench in 12 hours. I can speed that up by throwing it in the pressure pot for about 20 minutes. But the bond itself does not need light cure, and it should never go back into the base curing unit. Okay. What was the second part of that, Jim?
Do you have to? Is there like an additional step that you physically have to clean up any adhesive?
Clean it up, right?
Clean it off, take it off, remove it.
Gotcha.
Excess.
Right. Yeah. So if you have used some of the other workflows, like the uncured resin and those types of things, where you filled it up, typically those have excess which spill over, that fills those gaps that you have to go back in and clean up. That again, our bond is not meant to be gap filling, that we're working with a 20 micron gap, so there should be no gaps to fill. It should be a very precise fit. And again, we just want to wet those tooth pockets and that tooth. There should not be a lot of excess. It shouldn't pool and it shouldn't spill over, which means that there should be very little, if any, cleanup when we get done. Okay, I showed you, let me see if I can show you again here. Here's an example. Let me see if I can focus in on here. If you guys can see that, these teeth on this side, I have just glued in. I've done nothing else. I polished this and glued the teeth in, and that's it. I didn't have to, there's no excess. There's nothing I had to clean up. That's it, just like that.
Great. That makes that workflow pretty easy.
Yeah.
Seamless. If the gap seems too large, whether it's printed or milled, how do they fix it? The adhesive gap, I assume they're talking about.
Yeah, the adhesive gap. Let's see if I can show you here. Yes. And again, it's set the default, and I'll show you here as soon as it calculates, is set to 20 microns. That at 20 microns, I have yet to have anybody tell me that was too big. Okay, if you find that it's too small, like you're having, those teeth are, very tight, and you're having to really push them to get them in there, they're too snug. Again, I haven't seen much of that, but you can actually increase that tooth gap, from 20 microns to maybe 50 microns if necessary. Although I've done a lot of testing, and almost everything I do is at that default 20 microns. That I wouldn't change it unless you see a specific issue. So here under pre-manufacturing, again, if we selected the VITA VIGO teeth, it should automatically change this glue space here to 20 microns, which is 0.02. It should automatically set that, although this is another one of those areas that I usually say it's a good practice to get in the habit of just double checking. Because if you select something else when you're doing the lab order, this default glue space is actually 0.50 microns, so 500 microns. So it's way too big. So you want to make sure that it is 20 microns. Did I answer the question?
Yeah. So
okay.
Another question on using the VMLC, the window in between the inner proximals. The question is, how long does it take to cure that material?
So the VMLC is your standard light cure composite. It's going to depend on which light curing unit you're using, but it's just a very few minutes. I don't know, Jim. What do you usually use?
Yeah, it's going to vary on the box, the UV light box that's being utilized. Some work better than others. On the clinical side, even an optical, a clinical operatory curing light actually works quicker, but that's like individual areas, where the curing box, it can take anywhere from 8 minutes to more, again, depending on the box itself, to do a final cure. So it takes about a minute, 2 minutes to attack it, but you should always do a final cure as well.
Yeah. Thank you, Jim.
Yeah, and then we often get this question, what is the minimum vertical space required to have the teeth not protrude through the gingiva? Is there a minimal spacing vertical? Have we figured that out yet?
Well, let's see. The, clinically, the standard gap between arches is 22 millimeters, and you know that's that's a clinical standard, regardless of whether it's digital or analog. And if you're able to reach that clinical standard, all of our teeth will fit well within that. Um, you know, if we start seeing issues of, the teeth penetrating the denture base or not enough vertical clearance, it kind of comes down to a case by case basis. A lot of times it's a clinical issue. There are a couple of workarounds. We discourage, um, having those teeth penetrate the base because then you're losing gluing area for those teeth, and it weakens the denture. For most, but like I said, if you meet the clinical standards, then our teeth fall well within that. If you're having issues, call me and I can give you some suggestions on that.
All right, excellent. So as we kind of wrap this up, Paul, I just want to go over a few things, and then we'll do some more questions as they come in. So
Okay.
for everyone, CE, you'll receive an email to direct you to how to get those CE credits. So please send us an email if you need to. Marketing at VITA North America or education at VITA North America, and we'll get you synced up with some CE credits. It has been recorded, this program. However, it's going to be a private, non-public link. So just if you need that, let us know if you don't receive it in your email that you've registered with, and then you can review these as you get back, later or your team and so forth. We also have video. Paul's done a tremendous number of other webinars and videos. You can go visit us on the VITA social websites, the YouTube, the LinkedIn, Instagram, Facebook, and see some of those additional learning webinars that we've done and videos. We are here to help you. Paul is there. Paul gave you his information earlier. So here's Paul's information again. You can also contact both of us at help@vitanorthamerica.com. Please do so if you need some additional help or support. We're here to help you. We also would like to get you connected with your local rep as well. So whether you're U.S. or Canada, this is a list of all the reps, local reps that can help you out. Again, if need be, get a hold of Paul or myself, the help desk, and we will steer you towards the right rep as well. And then stay tuned for more additional programs. So this is a kind of a unique one that Paul does with the hands-on that we do here for the VITA Learning webinars. We do others as well. You can see Paul May 10th, LMT online. And then we have others, whether they're denture, whether there's porcelain, whether there's digital dentures, traditional denture teeth, and so forth. We're doing some class 2, class 3, some combination syndrome casework as well with Mark Wagenseal down the road. So these are some dates that we have additional webinars going on, training programs. And you can see the full list there at vitanorthamerica.com/courses. And let's double check, see if there's any more questions here.
And one last thing that I forgot to mention, which I probably should real quick, is the question I get is, can you reline and repair these digital dentures? And the short answer is yes, you can. That the material is totally compatible with whatever reline or repair cold cure material you're used to working with. It bonds great. It works very well. And so there's no problem relining or repairing these digital dentures. Although, as we move forward with this technology and the digital manufacturing gets cheaper and faster, I'm expecting to see less and less people actually repairing or relining dentures, because it is getting to the point where it's almost faster to simply make a new one than it is to reline or repair them. So you can do it either way. You can either make a new denture or you can reline and repair it. Any other questions?
Yeah, so get back a little bit back to the VMLC. Another question, how long is the working time of the flow gingiva material, and what's the best way to keep it from not pooling in your experience?
Oh, well, the working time on that is a light cure, but the overhead light isn't going to set it off real quick. You have more than enough time, working time with it. As far as pooling, the flow, even though it is a little runnier than the paste, it still is not super runny. That it usually has a pretty good consistency. That if I want to thin it out more, then I'll use some of that modeling liquid. So I can kind of vary the thickness of that VMLC depending on how much modeling liquid I put in it. Does that answer your question?
Yeah, very good. And then, of course, if they need to thicken it up, there is the complementary paste VMLC material that you could use. It looks just like the flow, but it's a little bit more pasty. That can also be mixed in with that flow material as well to thicken it up if need be. Another question is, printer mill, does the adhesive gap change?
Shouldn't. We've tested it both ways, and in my experience, it shouldn't. If there needs to be an adjustment, I have some of the people that are printing that have adjusted it a little bit, but milling, there shouldn't be any adjustment at all.
All right. So, Paul, you have any last thoughts you want to communicate to the team out in the world?
Oh man, I could talk about digital dentures for the rest of the day, but I'm sure everybody's had enough. If you guys have any other questions, please feel free to call me, and I'll be happy to discuss it with you, or email me. Again, I've got tutorials on all the stuff that I showed today. So if there's something you missed or had more questions on, I can send that out as well. So.
All right, fantastic. Well, Paul, again, thanks for taking the time to do this webinar. Another outstanding program, and I'm sure that the audience has, learned something. There's always something to learn from yourself and how this workflow goes. Everybody's still trying to get their mind wrapped around going to digital dentures. We've had digital crown and bridge for a long time, but now digital dentures and introducing themselves into it. I think you did a great job to explain the thorough end-to-end workflow. I'd like to thank the entire audience for participating, for joining us on this webinar. Thank you very much for participating and just being connected to the dental market, learning more things, looking forward to bring more digital dentures into your environment, into your workflow, trying to streamline your processes, which, we feel that we've got some products that really do that for you. So I don't see any other questions. So Paul, I think that we are going to conclude this webinar. So I want to thank everybody again. And this now concludes this VITA Learning webinar with Paul Richardson. Thank you for attending.